Hi everybody, welcome to the pre-recording for lesson 13.3. You will notice that there is no pre-recording for lesson 13.2. We're skipping right from 13.1 to 13.3. You do have to do lesson 13.2. It's just that I won't be doing a live lesson for that lesson. So I do have Mrs. Owen's recording posted. So you will want to use that to work on the formulas for the area of trapezoids and kites. So today we are going to be looking at the area of a regular polygon. And the area of a regular polygon isn't going to be, there is a formula for the area of a regular polygon, but when we look at this, it's not going to be as formula-based as much as reasoning-based. And a lot of what we worked with in live lesson for lesson 13.1 with rectangles, parallelograms, and triangles was piecing things together, thinking about what you had and what you didn't have. And that's what you're going to do here. And we're going to take these regular polygons and we're going to cut them into pieces, and we're going to be analyzing those pieces to figure out what we need to put into the formula. So first thing we need to understand is what is a regular polygon. And all of you should already know this. We've done this this year. Remember, a regular polygon, let's say 1, 2, 3, 4, 5, 6, 7, 8. It didn't come out very well. Let's do it straighter. A regular polygon, all of the sides are congruent. So this was an 8-sided polygon. All the sides are congruent, and all the interior angles here are congruent, as well as the exterior angles are congruent to one another as well. So in order for us to have a regular polygon, we have to have all sides congruent to one another and all the interior angles congruent to one another. If it's not a regular polygon, we're not going to be able to find the area by the means that we're going to learn about in this lesson. You can always try and break it into pieces that we do know formulas for the area of and things like that to try to solve some sort of polygon that's not regular. But we can only deal with regular polygons using the method that we're going to learn in this lesson. Now what we're going to do here is we're going to, when I say diagramming a polygon, we're going to pull this polygon apart. Okay, so you can see the polygon right here. So let me kind of get in yellow here. Here's the polygon right here that's in this diagram. Okay, you see there's a circle drawn around it. The only reason the circle is drawn is just to get you to understand that when we talk about the radius of a polygon, we're talking about the length from the center of the circle out to the circle, edge of the circle. Okay, and the only places where this polygon touches that circle is at each vertice. Okay, so the radius of a polygon is going to be a distance from the center out to one of the vertices. And now you see if you draw a line from the center at each radius, draw a line for each radius that goes out from the center of the circle to the edge of the circle, or from the center of the polygon to each vertice, you're going to create a bunch of triangles. And that's exactly what we're going to be analyzing, this group of triangles. And the number of triangles will be equal to the number of sides. In this particular figure, we have 6 sides, so there are 6 triangles. Up here, we had 8 sides, so we draw all of our radii there. Very poorly, but you've got to use your imagination with Mr. Troutman's drawing skills. So if we draw that, we're going to have 8 triangles. Okay, and those triangles have a very special feature. And the big feature is that we're also going to draw an apothem. Okay, and an apothem is going to be the altitude of each of these triangles. Okay, so an apothem goes from the center of the polygon out to the middle of each side. Okay, it means it's going to come out and meet each side at a right angle. Okay, and it's going to split each of those triangles into 2 congruent triangles. So you can see the apothem going down here, meeting at a right angle. So that's going to split each of these triangles into 2 right triangles. Okay, again, depending on how many of these sides you have or how many triangles you have. So what you're going to have then is a radius, a center, and an apothem. Okay, those are 3 things that are going to be important. The radius is going to be the side of each of those triangles. Remember, radius is the same everywhere around a circle. So all of these sides are congruent, which means we have isosceles triangles. So next up, we've got them split into right triangles. Okay, so we've got 90-degree angles, and we've got these sides here. So the last thing we're going to want to do then is be able to say to ourselves, what else can we know about any given polygon? Can we know the measure of any of these angles besides the right angle? And you can, and that's what we're going to do on the next page. So let's take a look. Okay, so let's take a look at this problem here. So the figure below is a regular hexagon. Okay, remember a hexagon has 6 sides. So this is a regular hexagon, so we know that all of these sides here are going to be congruent. Okay, and so are all the angles. Okay, and I'm not going to draw those, just keep the clutter down. With radii and apothem drawn. Okay, the radii are what's going out to each vertice, right, and creating each of these triangles. Those are all the radii. And then the apothem says that this is an apothem. By definition, that means we've got right angles here. Okay, splitting this triangle, lower triangle here in half, and there can be an apothem on each of these. We don't need to draw them all, but there can be an apothem on each of those triangles, splitting it into 2 right triangles and 2 congruent right triangles. So then it says, what is the measure of each numbered angle? Okay, so let's take a look. First of all, think to yourself, the measure of angle 1. Remember, all of these angles are going to be the same here. So 1, 1, 1, 1, 1, all going to be the same. So how are you going to figure that out? So take a moment, just hit pause, think for yourself. How do you know what those angles are? You've actually done this before in class. And if you look at it, you're going to say, well, wait a minute, Mr. Troutman. There are 6 of these triangles, right? And everything is symmetric and congruent. So if all of these angles are the same, then going all the way around here is 360 degrees. So if I've got 6 triangles, then we're going to have 360 degrees divided up 6 ways into 6 pieces of each piece of the pie there. So that's going to be 60 degrees. So then each one of these angle 1s here is going to be 60 degrees. Okay, so you got to look and say, how much am I dividing that 360 degrees into? Because it's always 360 degrees all the way around the circle there. How many parts am I breaking that 360 up to? Okay, so now let's take a look at the next angles here, 2 and 3. Let's do 3 first. Okay, remember now, this apothem is an altitude. It's breaking this straight down the middle, okay, into 2 right angles and breaking it into 2 congruent right triangles. Well, that means that you're splitting that in half, right? So angle 3 is going to be 30 degrees. Each one of these, if we take one up here, we split into 30 and 30. Same thing over here, draw an apothem, 30 and 30. So angle 3 is 30 degrees. Okay, now what's angle 2? Well, let's do ourselves a little bit of triangle angle sum theorem. So if you've got 60 degrees up here, think about angle 2. How would you know what angle 2 is? Okay, you can either use the 90-degree angle or the fact that you've got isosceles triangles. So I want you to tell me what angle 2 is in the Google form, and then I am going to go over it real quick before we move on to actually finding areas.